4 Fs, and now she doesn't. So that's better.
Yeah. Well, with everything just being daily averages, you know, she has a string of zeros, but they don't affect her all that much because
Yeah.
it's only 15% of their pay.
Hi, Sid. Hi, Nick.
When they got on here last time, when you left, and then somebody buzzed in,
Yeah.
I couldn't figure out how to get them on.
Well,
I just let them go till
Yeah.
they quit buzzing.
They're not supposed to have to log in or have
Oh.
my permission anymore. I changed that, changed automatic recording. So hopefully all of it's better.
Okay.
So, and then I'm using your class as an excuse to get back down here. So I'm just going to leave it, and
Okay.
then I'm going to go finish that one and come right back.
Okay.
Because I need to come down here and do actual work today.
Where's quiet?
Who else we have to come on?
It's like Parker, as per usual.
Is Joe on?
No.
He's working.
Oh, that's a likely excuse. Kylie's on, Matt, Addison, Jordan, Abby, Garrett, Nikki, Danae, Lane. Who am I missing?
No, he's on. Sorry, Parker. Just Parker and Joe.
Okay, we'll go ahead and get started and we'll come out. Now remember, this is, we're getting close to the end. We're going to try to finish up Thursday of next week. We'll try to do that. So yesterday or Tuesday, I gave you 4 problems. You were supposed to find the area underneath the curve. And I did those. So I'd like to talk about them a little bit. On that first problem, it said that you have you want to find the area that's bounded by y is equal to the cube root of x, y is equal to 1 over x, and x is equal to 8. Okay, so I came up with this equation. When I drew it, the top curve was the cube root of x. And the bottom curve was 1 over x. So if you take the top curve minus the bottom curve, that gives you the height of the rectangle. And then dx is the width. So that's what I came up with. Anybody else come up with that?
I did.
Okay, and then integrate it from where to where?
From 8 to 1.
Integrate from where to where?
8 to 1 to 8.
Integrate from where to where?
8 to 1.
Okay, we go 1 to 8.
Okay.
Now, very quickly, I got this equation from the drawing. Because this is the drawing, this top curve here is the cube root of x, and this curve is 1 over x. And then this is x equals 8. So I want to find the area here. The height of this rectangle is the cube root of x minus 1 over x. The width is dx. And you're starting here at 1, and you're ending here at 8. And so that's where I got it, all right? And then integrate. This is x to the 1/3. So you add 1 to the exponent, divide by that new exponent. This is 1 over x. The antiderivative of 1 over x is the natural log of x plus c. And you're going to go from 1 to 8. So if you put in the number 8, and if you do this on a calculator, that's fine. I did everything by hand, and then I double checked it on the calculator. If you put in x is equal to 8, then the cube root of 8 is 2. 2 to the 4th is 16. 16 divided by 4 is 4. And then 3 times 4 is 12. And the natural log of 8, I don't know. When you put in the number 1, you're just going to get 3 over 4. And the natural log of 1 plus c. And then you have to subtract these two answers. So you put in the largest number first and the smallest number second. So c minus c goes to 0, period. Right? The natural log of 1 asks that this is e to the 0 power equals 1. So this answer is just 0. The natural log of 1 is just 0. Right? So then I just took it, and then if you take 12 minus 3/4, you get 11 1/4 minus the natural log of 8. Now that would be an exact answer. And if you left it like that, you would be fine. I just punched it into the calculator. 11.25 matches minus the natural log of 8. And I got a value of 9.17. Did anybody else get 9.17?
Yeah.
One got, Abby, you got 9.17?
Yeah, I did.
Anybody else?
I got 9.15.
That's close enough.
Yeah, I got 9.17.
That's
did I.
close. That's good. Anybody else? The problems are not difficult, okay? The only one to me that was difficult was number 2. Okay, and that's the only one that I had a difficult with. And it was easy, very, very easy to set up. It wasn't quite so easy to find the integration. So this one says that y is equal to or e to the x. And then y is equal to x times e to the x squared. And then x is equal to 0. So we're going to try and draw this. And I just did some substitution. If x is 0, then y is equal to 1. If x is 1, y is equal to e, which is 2.718. And if it's 2, e to the second power is 2.718 times 2.718. Anyhow, it's up here. So that's what that graph looked like. Okay. I have no idea what this is, but I just put in numbers again. If I put in 0 for x, I get 0 for y. If I put in 1 for x, I get 1 times e to the first, which is just e to the first. That's this answer right here. Okay. So this curve comes like this. And then you have x equals 0 is the vertical line. So you're just going to find this answer right here. See? So the top curve minus the bottom curve, that's the height of that rectangle. Dx is the width of the rectangle. And we're going to go from 0 to 1. That's all the farther it went. So it's fairly easy to draw it. And it's fairly easy to get the equation that you want to use. Top curve minus the bottom curve is the height of the rectangle. Dx is the width. Well, let's take the antiderivative or the integration. The integration of e to the x is itself. Minus, now we have to integrate x times e to the x squared. Okay? That has to be done by substitution. So very quickly, I just took this on, went to a piece of scratch paper, and I integrated x e to the x squared. So I just took a piece of scratch paper and I integrated x e to the x squared dx. So I let u be equal to x squared. So now this problem looks like this. You just replace the x squared with the letter u. The derivative is 2x. So in place of the derivative, I put du over 2x, which made the x's cancel out. Okay. So this is just 1/2. Now the antiderivative of e to the u in terms of u is just itself. So the antiderivative of e to the u is just itself, but u is equal to x squared. So this was the answer to the antiderivative. I had to do that by substitution, no other way to do it. So then I come down here and I plug this in. So the antiderivative of this is this. And we go from 0 to 1. So if you put in the number 1, you have e to the first minus 1/2 e to the first plus c. If you put in the number 0, you have e to the 0 power, which is 1, minus e to the 0 power times 1/2 is 1/2. The c's cancel out because you're going to subtract them. So this is just 1/2. And then this is just 1/2 of e. So e minus 1/2 of e is 1/2 e, and 1 minus 1/2 is 1/2. So your answer is 1/2 e minus 1/2. On a calculator, that's 0.86. 0.86. Very small number because this is a small area. It's not even 1 unit. The answer for number 7 is 4.5, exactly 4.5. And the answer for number 13 is 72. And we're going to look at 13. Because it has 12 minus x squared and what's the other one? X squared minus 6. Yeah. Now, this is just the parabola turned upside down and moved 12 spaces up. So that's the answer. That's the graph of 12 minus x squared. This is the parabola moved down 6 spaces. So that's going to be it. So if you put in one rectangle, the height of that rectangle, the top curve minus the bottom curve. So the top curve is 12 minus x squared. The bottom curve is x squared minus 6. and the width of that rectangle is dx. So this is the height of the rectangle. This is the width of the rectangle. Now I did this arithmetic. I took negative x squared minus x squared is a negative 2x squared. And I took 12 minus a negative 6, and that's a positive 18. 12 minus a negative 6. Okay. So that's the height. This is the width. We have to integrate it from this x value to this x value. Because we're going to go sideways when we put in these rectangles, we got to fill it in from this x value to this x value. Okay. And if you choose in enough points, if you just did it by graphing by hand and put in points, you could see what it is. But if you just drew it like I did, these 2 points is where this graph and this graph are equal. So if you want to find out the exact value of x, you put this curve equal to this curve. So if you add x squared to both sides, add 6 to both sides, divide by 2, you get x squared equals 9. So x is equal to plus or minus 3. The square root of 9 is 3, either positive or negative. So this is a negative 3, and this is a positive 3. I don't need to know the y value because we're integrating in terms of x. So we're going to go from negative 3 to positive 3. Antiderivative, add 1 to the exponent, divide by that new exponent, go from negative 3 to positive 3. Okay. So if you put in a positive 3, 3 to the third is 27, divided by 3 is 9, times negative 2 is negative 18. If you put in 3 for x, you get 18 times 3 is 54. If you put in negative 3 cubed is negative 27. Negative 27 divided by 3 is negative 9. Negative 2 times negative 9 is a positive 18. 18 times negative 3 is a negative 54. Plus c, subtract the 2 answers. So you're going to get c minus c is 0. You got a negative 18 minus 18, negative 36. You got 54 minus a negative 54 is 108. 54 minus a negative 54. And 108 minus 36 is 72 exactly. So the area, the number of squares in there is 72. So you have that assignment, those 4 problems. What I want you to do is to add 4 more. So you had on page 434, you had 1, 2, 7, and 13. We just went over 3 of those. Add to that list, add 8, 14, 18, and 22. 8, 14, 18, and 22. Okay. Now, there are other ways that integration problems are used. The number 1 way is to find the area underneath curves, the areas that don't have formulas. Areas of rectangles, we just use base times height. Triangles, 1/2 base times height. Circles, pi r squared, so on. But if they don't have formulas, then we have to do it by calculus problems. We have to do it by integration. Okay? There are others that are used. They find volumes. They can find centers of gravity. They can find the amount of work needed to pull something up out of the ocean, all sorts of different things, but we don't have enough time to get into that. Okay? So that's your assignment. That's going to be the one that's going to be Tuesday. And for the last 20 minutes or so of this period, what I want to do is I want to talk about another method of integration. So there are three major ways that we find we do integration problems. That's the major way. The antiderivative of x to the n is to add 1 to the exponent and divide by that new exponent. That's number one on the hit parade. Now, along with that are some definitions. The antiderivative of e to the x, the antiderivative of 1 over x, the antiderivative of sine x, the antiderivative of cosine x, the antiderivative of 1 over 1 plus x squared. Those are definitions and they're found on page 403. That's part of this. The second method we've already talked about is integration by substitution. Okay. And if we integrate by substitution, we're going to replace one of the variables with a different letter. And we're going to integrate it in terms of that letter and then take it back to the original. And we've talked about those. Those were the problems on page 418, integration by substitution. The last one we want to talk about and we're going to go over this today, is integration by parts. Now, there's a couple more integration methods, but these are the major three. Okay, if you can't do it by this, then you try to do it by this. If you can't do it by this, then you try to do it by this. Okay. Now, in the back of the book, if you go to the reference pages, and they're almost like, in terms of cardboard, they're not paper, at the back of the book, you have reference page 1, and those are the algebra geometry formulas. Reference page 2 are the trigonometric formulas. Reference page 3 are graphs of functions. Reference page 4 are special functions, the hyperbolic functions, which we do not mess with. Page 5 on the back of the book, the reference pages, are the differentiation rules. How do you integrate? And they have the list of formulas right there. And then if you turn to page 6, there's a table of integrals. Now, the first 16 are basically, number one, the rules of integration, and then you can look up some of the others. From 16 to 112 in this page, in this book, they have 112 different formulas for integration. And those 112 come from these three methods. So from 16 to 112, and you look at all those formulas and see, for example, number 21 says, let's take the antiderivative of a squared plus u squared du. Well, if you replace the letter a with a constant, and you place the letter u with whatever variable you're using, then you can use that formula to find the antiderivative. So I'm just going to give you a quick example. If I wanted to find the square root, the antiderivative or the integration of 4 plus x squared. Well, you can go quickly right to the answer. This is going to be a squared. This is going to be u squared. So a is going to be equal to 2, and u is going to be equal to x. So you're going to have 2 squared plus x squared. And then we're just going to write the answer based on the formula. It says that you take u over 2 times the square root of a squared plus u squared plus a squared over 2. And so that would just be 2. And then times the natural log of x plus the square root of a squared plus u squared plus c. So that's the formula for number 21. If you ever have to integrate this, there's no formula for it, no antiderivative formula for it. You cannot do it by substitution. You cannot do it by integration. You go to this page and you write it out. Now, how they got to that, I don't have any idea. But they seem to think it's really neat. Okay? So we're going to talk about integration by parts today. Does anybody remember how to take the derivative of a multiplication problem? There was a rule, how you take the derivative of a multiplication problem. What was that rule? Danae, you have any idea? Danae?
Wasn't it something?
Pardon me?
Wasn't it something like the derivative of the first term times the second term plus the derivative of the second term plus times the first term or something?
Okay, it's if it's actually you've got it, but we're just going to put it in a different order. The derivative of a multiplication problem, remember, was the first term times the derivative of the second plus the second term times the derivative of the first. Okay, that was the derivative of a multiplication problem. That's how we find it. Okay, what is the what is the opposite of the derivative? Matt? What's the opposite of the derivative?
Antiderivative.
Antiderivative, exactly right. What's the symbol for antiderivative? What's the symbol for the antiderivative? Addison?
Would it just be the integration symbol?
Yes, just the integration symbol. Okay, so we're going to follow the rules of algebra. The opposite of the derivative is to integrate. Whatever you do to one side, you do to the other side. So we're going to take the antiderivative of both sides. Well, the antiderivative of the derivative cancels out, so you just get u times v, period. This would be u. Now, instead of writing v to the symbol for derivative, I'm going to put dv. That's the derivative of v. This is u times the derivative of v, and I'm going to put dv. Okay? Plus, this is v, and I'm going to write this as du. Then I'm going to write this in terms of a formula. Okay? The opposite of adding is to subtract. Whatever you do to one side, do to the other side. So this cancels out. So I'm just going to move these from side to side. The antiderivative of u times dv is going to be equal to u times v minus the antiderivative of v times du. Okay. So we just took the antiderivative of both sides. Then we moved this to the other side. And then we wrote this is equal to that. Okay. And I'm going to write this up at the top of the page. And that's a formula for integration of parts. Right? So I want you to notice that there's the letter U, there's the letter V, there's the derivative of V, and there's the derivative of U. So in this formula, there's 4 variables. Okay. All right, let's see if we can't do something. Okay. We'll start out with something fairly simple and then see where we go from that. So we're going to do this problem. We're going to take the antiderivative or the integrate x times sine x dx in terms of x. So we're just going to write that out. And we're going to get rid of some of these things in here. I'm going to let, the first part, I'm going to let u be equal to x. So we're going to divide this up into two parts. We're going to divide it up into u times dv. So we're going to have x. The rest of this then has to be the derivative of v. So we're going to divide this up into two parts. Part of it is going to be u, the other part is going to be dv. We have that way. Okay. And then what is the derivative of u? Well, the derivative of u has to be equal to the derivative of x. And the antiderivative of dv is v, and the antiderivative of sine x is negative cosine x. We let u be equal to x. We let the derivative of v be to the rest of it. If you take the derivative of u, you get the derivative of x. If you take the antiderivative of dv, you get negative cosine x. Now, here's your four parts. I said there were four parts to the problem. You have 1, 2, 3, and 4. You just substitute them in that formula. So the answer to this problem is going to be u times v, which is x times negative cosine x. So you just follow the formula. It's equal to u times v minus the antiderivative of v times du. Okay. Whoops, I put it in the wrong spot. That's right, it's supposed to be here. So we have the first part and the second part. Take the derivative of the first part, antiderivative of the second part, you have 4 letters. Now, we're done. A negative times a negative is a positive. What is the antiderivative of cosine x? We know that. What is the antiderivative of cosine x? Page 403. Antiderivative of cosine x. Anybody?
Negative sine x.
No, just positive sine x. Plus c. So you're done. We're going to take the antiderivative of x squared e to the x. We can't use the formula, and you can't do it by substitution. So now we have to go to parts. So I'm going to let u be equal to x squared, the first part. And the second part is going to be the derivative of v. So I'm just going to separate this into two parts. Call one part of it u, the other part of it is dv. Okay. So the derivative of u is 2x dx. So du dx equals 2x, and then move dx to the other side. The antiderivative of the derivative of v is v. The antiderivative of e to the x is itself. Now you have the answer. The answer is u times v, which is x squared e to the x, minus the antiderivative of v times du. So you divide the original problem into two parts. You take the derivative of the first part, the antiderivative of the second part. So the answer, according to the formula, is u times v minus the antiderivative of v times du. So this answer is going to be x squared e to the x minus, what's the antiderivative of 2x e to the x? I don't know. I can't find it in the formulas. I can't do it by substitution. So I'm going to have to do this part again by parts, all by itself. And I'm just going to put it down here. Or sometimes I just do it on scratch paper. But I want the first part be equal to u, the second part to be equal to dx, dx or dv, excuse me. The derivative is just 2. The antiderivative of e to the x. So we're going to put that answer right here. So the antiderivative of 2x e to the x is going to be u times v minus the antiderivative of v times du. So we have minus 2x e to the x. And then a negative times a negative is going to be a positive. And the antiderivative of 2e to the x is itself. Plus c. So we had to use the rule twice. Doesn't happen very often, but it does happen. The antiderivative of the natural log of x does not exist. Okay, we don't have it in the list of formulas. You can't do it by substitution. We're going to do it by parts. So this is going to be the first part, and this is going to be the second part. Because we always divide it up into two pieces. The first piece is u. The second piece is dv. The derivative of u dx. What is the derivative of the natural log of x? The derivative of the natural log of x. Nikki.
Isn't it 1 over x?
And you're right, it's 1 over x, okay? So the derivative of u is du, the derivative of the natural log of x is 1 over x dx. The antiderivative of the derivative of v is v, the antiderivative of dx is x. There's your answer. The answer to this problem is u times v, according to the formula. You take u times v, which is x times the natural log of x, minus the antiderivative of v times du. Well, here's v, and here's du. Well, if you multiply these, what happens to the x's? They cancel out. So you're done. What's the antiderivative of 1 in terms of x? Add 1 to the exponent, divide by that new exponent. This is 1x to the 0. So when you add 1 to the exponent, divide by that new exponent, you just get x. Because x times 1 over x cancels out. Last example. And here's just a secret, a tip, if you will. If there's a natural log of x in the problem, let that be equal to u. It just seems to work out better that way. And so you're going to have two parts. The first part is u. That's going to be natural log of x. The second part is going to be the rest of it. Well, the rest of it is x squared dx. So if there's a natural log in the problem, let it be equal to u. dv is whatever's left. Well, what's left is x squared dx. So the derivative of the natural log of x is 1 over x dx. The antiderivative of dv is v. The antiderivative of x squared, add 1 to the exponent, divide by that new exponent. Write the answer. The answer is u times v, which is x to the third over 3 times the natural log of x, u times v, minus the antiderivative of v times du. Well, here's v, and here's du. So if we just do some simple arithmetic, we're pretty much done. This x to the third divided by x is going to be x squared. And the antiderivative of x squared is x to the third over 3. Because you're going to add 1 to the exponent, divide by that new exponent. So this is going to give you x to the third over 9. Because you already have a 3 on the bottom. So when you have x to the third and you put a 3 on the bottom, that becomes a 9. So the antiderivative of this is this. We're going to do that more on Tuesday. And that's the last thing that we want to talk about is doing the antiderivative or doing the integration by parts. So you have your assignment. You're going to add 4 more problems to those area problems. Top curve minus bottom curve, antiderivative, write the answer down. So page 476, problems 1, 2, 3, nope, back up, I'm sorry. Page 434, 1, 2, 7, 13, which we've already done. Add 8, 14, 18, and 22. And so those 8 problems will be due on Tuesday. And if you want to get them done and send them to me, that's fine. On Tuesday, we will look at those problems, the area problems, and then we'll talk a little bit more about integration problems by parts. And then I want to do a little bit of work on Thursday, end of the year stuff. What you need to have into me, what I need to get from you, all that kind of stuff, some logistics, year-end logistics. Okay, thanks for checking in. We will continue this on Tuesday, same time, same station. Thank you.
Thank you.
Thank you.
Thank you.
Bye, guys.